Not every system is going to be a walk in the park. That means you're going to have to do a little work, and you may have to change one of your equations to x equals or y equals. The best thing to do is to look at your system and see which one is the easiest to switch to. I'm looking out of the two that I have. I figure my top one is the easiest one, and you can decide to change it to x equals or y equals. I'm choosing to change it to x equals. It's just really easier if I just move the y over to the other side. So instead of x minus y equals 6, it's going to be positive y plus 6. Or you can do 6 plus y. It doesn't matter. Now that I have my x value, I can now substitute this in for my x in the other equation. Again, open parentheses. And our x variable is y plus 6. Distribute your 8. So I get 8y plus 48 minus 3y equals negative 7. Combine your like terms. 8y minus 3y is 5y. I'm going to subtract 48 from both sides. And that should give me negative 55. And then I'm going to divide both sides by 5. Which gives me negative 11. So now that I know the y equals negative 11, what do? Plug it back into one of your original equations. Now, even though I changed my first equation to this, he's still considered an original equation. So I can use that to plug in my y. So now, let's do a little math. What's negative 11 plus 6? X equals negative 5. So that means our solution is negative 5, comma, negative 11. Here's another example where you have to change one of your equations to x equals or y equals. Again, look at your system that you're given and decide which one's the easiest to change to. In this case, I'm looking at my second equation, x minus 3y equals 6. Looks like it's fairly easy. But if you think the first one's easy, you can also choose to change that one too. But I'm choosing to do the second one. And I'm going to make this one an x equals. So I'm going to take minus 3y and move it over to the other side. So now it's 6 plus 3y. That's going to be my new second equation now. Now that you know what x equals, remember we're going to substitute this expression into the first equation for x. So I'm going to rewrite my first equation. Substitute in my expression. And now I'm going to solve for y. 2 times 6 is 12. 2 times 3y is 6y. Bring everything else down. Combine your like terms. 6y plus 4y is 10y. Now I'm going to subtract 12 from both sides. Yes, 0 is a number that you can get in a problem. And then I'm going to divide both sides by 10. And 0 divided by 10 is 0. Okay, so now that you know your y variable, what do? That's right, you plug it back into one of your original equations. Remember that one we changed, he's still considered an original equation also. So I'm going to use him to plug it back in. So we got 6 plus 3 times 0. 3 times 0 is just 0. So that means x just equals 6. So what's our final solution? 6, 0. In the world of math, not everything has an exact solution. Let's work this problem to see what I'm talking about. If I look at my system, I notice that both of my equations are written in standard form. So that means I have to choose one of them to make it x equals or y equals. Okay, I'm going to choose the first one. And I'm going to move my work over here. So let's see, it's 2x plus 3y equals 6. I'm going to subtract 2x from both sides. And I'm going to divide each term by 3. Remember, if you can't divide evenly by a number, just leave it as a fraction. Okay, so now this is my new number 1 equation. And now that I know what y equals, this is the expression that I will substitute in to the second equation's y. So it's 4x 6 parentheses, and remember what my expression is, it's 2 minus negative 2 over 3x. Okay. I'm going to distribute the 6 over. I get 4x. 6 times 2 is 12. And here's the tricky part. 6 times negative 2 is negative 12. And negative 12 divided by 3 is a negative 4x. Aha. Okay, I'm going to combine my like terms. 4x minus 4x is 0. Uh-oh. And all I'm left with is 12 equals 12. What kind of solution is this? I remember. This is a true statement, right? And when you have a true statement that 12 equals 12, then that means your solution is infinite. This only happens when you have a number equals itself. Here's another system that may not exactly come out to an actual number. Again, look at your system and see if you have to change anything to x equals or y equals. I'm looking at mine and I'm going to choose the first one. I'm going to change that to y equals. Move my work over here. So that's 5x minus y equals 8. I'm going to subtract 5x to the other side. Don't forget to bring down that negative y. Some students forget to do that. And then I can't have a negative y equals, so that means I have to divide every term by negative 1 to change them all to positives. So now I get y equals negative 8 plus 5x. Okay, remember this is going to be our new equation, and this is what we're going to substitute in for y into our second equation. So let's see, we get 10x minus 2, open parentheses, and here's my expression that I'm going to substitute in. Negative 8 plus 5x. Okay. So I'm going to distribute the negative 2 over. Negative 2 times negative 8 is positive 16. Negative 2 times positive 5x is negative 10x. Combine your like terms for your 10x's, and that goes away, I see. Uh-oh. This happened on our last problem. 16 does not equal 5. And if 16 can never equal 5, then what kind of solution is this? You guessed it, no solution. This happens when our numbers do not equal and all the variables cancel out.